Thousands of new worlds, some with oceans, others with 2 suns. Could one of them already have life? What are exoplanets? It are worlds beyond our cosmic neighborhood, planets that orbit stars other than our own sun. The idea of them has captivated humanity for centuries, but they were purely science fiction until the late 20th century. The game changed forever in 1995, with the discovery of 51 Pegasi b, the first confirmed exoplanet orbiting a sun-like star. It was a hot Jupiter, a gas giant roasting in an orbit far closer than Mercury is to our sun, a type of world we never expected. Since that groundbreaking moment, our catalog of alien worlds has exploded. We have now confirmed the existence of over 5,000 exoplanets, and that number climbs higher every month. Each new discovery adds another piece to the puzzle of our galaxy, revealing a staggering diversity of worlds we are only just beginning to understand. So, how do we find these distant worlds, often hundreds or thousands of light years away? We use cosmic detective methods that are incredibly clever. The most successful technique is called the transit method. Imagine watching a distant streetlight and seeing a tiny moth fly in front of it. The light will dip ever so slightly. That's exactly what our telescopes look for, minuscule. Periodic dip in a star's brightness caused by a planet passing in front of it from our point of view. Another powerful technique is the radial velocity method or the wobble method. An orbiting planet's gravity doesn't just pull on other planets, it also pulls on its star, causing it to wobble back and forth. By measuring this tiny stellar dance through shifts in the star's light spectrum, we can infer the presence, mass, and orbit of an unseen planet. Finally, there's direct imaging. This is the holy grail of exoplanet, hunting taking an actual picture of a planet. It's incredibly difficult, like trying to spot a firefly next to a powerful searchlight from miles away. But with advanced telescopes like the James Webb Space Telescope, we are now beginning to capture these faint, distant worlds directly, opening a new era of exploration. When we talk about finding thousands of planets, we have to talk about the Kepler mission. Launched by NASA in 2009, the Kepler Space Telescope was a revolutionary planet hunter. For nearly a decade, it stared relentlessly at a single patch of the sky, monitoring the brightness of over 150,000 stars simultaneously. Its mission was simple but profound: to find out just how common planets are in our Milky Way galaxy. The results were staggering. Kepler discovered thousands of exoplanet candidates, proving that our galaxy is teeming with worlds. It revealed that, on average, most stars have at least one planet orbiting them. Thanks to Kepler, we now know that planets are not a rare exception, but a fundamental rule of star formation. It shifted our perspective from wondering if there are other worlds to asking which one's might be like Earth. The search for exoplanets has now entered its next, even more exciting phase, thanks to the James Webb Space Telescope, or JWST. While Kepler was a planet finder, JWST is a planet characterizer. Its incredible sensitivity allows it to do something that was once pure science fiction: study the atmospheres of distant exoplanets. When a planet transits its star, a tiny fraction of starlight passes through its atmosphere before reaching us. JWST can analyze this light, breaking it down into a spectrum that reveals the chemical composition of the alien air. It's looking for biosignatures, the chemical fingerprints of life. Gases like oxygen, methane, and water vapor, when found in the right combination, could be powerful indicators of biological processes. With JWST, we can start to understand a planet's climate, its composition, and, most importantly, its potential for hosting life. Among the billions of planets in our galaxy, scientists are most interested in those orbiting within the Goldilocks zone, officially known as the habitable zone. This is the region around a star where the temperature is just right, not too hot, not too cold, for liquid water to exist on a planet's surface. It's too close to the star, and water would boil away into space. Too far, and it would freeze into solid ice. The Goldilocks zone is the sweet spot where the conditions for life as we know it could be met. Our own Earth is perfectly positioned within our sun's habitable zone, which has allowed our vast oceans to remain liquid for billions of years, nurturing the evolution of life. Finding a rocky planet within the habitable zone of another star is the first critical step in the search for a second Earth. The thousands of exoplanets we've discovered have revealed a zoo of bizarre and wonderful worlds, many unlike anything in our own solar system. We've found hot Jupiters, massive gas giants orbiting their stars in a matter of days, with scorching temperatures that can vaporize iron. Then there are the super-Earths, rocky planets larger than Earth, but smaller than Neptune. These are some of the most common planets in the galaxy, and they are prime targets in the search for life, as they could potentially have stable surfaces and host deep oceans. We've also found mini-Neptunes, worlds that bridge the gap between rocky planets and gas giants, with thick, hydrogen-rich atmospheres. Each new category challenges our models of planet formation and shows that nature's imagination is far greater than our own. With all these worlds, the ultimate question inevitably arises: are we alone? The search is no longer just about finding planets, it's about finding habitable ones. Scientists are now combing through data from planets like TRAPPIST-1e or Kepler 186f, rocky worlds in the habitable zone that show tantalizing potential. We are searching for biosignatures, but also for technosignature signs of advanced technology, like industrial pollutants in an atmosphere, massive artificial structures, or intentional radio signals. The discovery of a genuine biosignature, let alone a technosignature, would be one of the most profound moments in human history. It would confirm that the spark of life has ignited elsewhere in the cosmos and would forever change our place in the universe. The sheer scale of the universe is almost impossible to comprehend. There are over 100 billion galaxies in the observable universe, and our own Milky Way galaxy contains hundreds of billions of stars. Statistically, with so many potential homes, it feels inevitable that life should exist elsewhere. The ingredients for life, carbon, water, energy, are common throughout the cosmos, yet we have not found any definitive proof. The silence is deafening, leading to the great cosmic mystery known as the Fermi paradox. If life is common, where is everybody? Till we find that first undeniable sign of an alien microbe or a distant signal. The question remains, maybe the next blue dot we find won't be alone. Are we truly alone?
Stay curious.